those are the previous three that basically the first three lectures you did, right? We did online.
The recordings?
Yeah, the ones that you were just showing us
Yes.
on Blackboard.
Yes.
Okay.
If you've got kids in the background, can you turn your mic off, down, or off, or mute? Thanks, Josh. That'll just help everything, everybody be able to hear. But by all means, if you have any questions, you can chime in, you can type. If I don't, like when I leave my screen, I don't see the questions. So if somebody reads a question or sees one, and other people that have a mic, some people don't have microphones. Someone could just blurt that question out, so that and I will check periodically. But so the dean of instruction, or the dean, Mike Klein, who is the division chair. They're trying to get an idea to see if there's any students in our classes that would be interested in going down to the school and do some lab time. So they were thinking about having it open between the 1st and the 27th of May. Now, obviously, our class is over on the 7th. So this would be purely if you want to go down there and work on the machine tools. My thought was I would be available the week after class is actually over for anyone on our regular scheduled class time to go down there for anyone who would be interested in working on the machine tools. So we can have no more than 10 people total. And what I'll do is I'll copy and paste that email and put it in the announcements. And so anyone that's interested, you can like text me and give me an idea how many people are interested in doing that. Like I said, it'd probably just be 1 week, and it won't be worth points or anything like that. It's just kind of we did have like 8 weeks of hands-on time, which I'm grateful for because it would be impossible to teach this class otherwise. So let's get right in. And first thing I want to do is kind of look at this Mastercam file, because I wanted to show you some examples while people are popping in here of some different outputs that Mastercam can program to. And one of the cool things about this is that you can program any machine tool that you have a post for. Whereas otherwise, you would have to learn all the different controls and all the different languages. But what we didn't do is we didn't create drill cycles for these 6 tapped holes. And I think, didn't we drill some holes, pre-drill for the end mill? If I remember it. No, we just went right in there and which we probably should. Oh, yeah, there's the 3/4 drill. So we'll just go in and to Mastercam, and I'll just briefly show you how to create those tool paths. So if you'll notice, I want my drill paths in front of the milling. So all I have to do is move this arrow up, and the next tool path will go in front of that. So that's kind of nice too. Right click in that area, and I'm going to scoot over here and pick drill. And it just takes you through this dialog box, a series of dialog boxes. And so it's prompting me to select one or more entities. So you got to be kind of careful here. If you select down in the chamfer, it sometimes can change your depth. So I always make sure I'm clicking on the top part of the, oops, see now that one took the corner. So I don't want that. I can delete that point. I deleted the wrong one, which is usually what happens. So since it's doing that, I'm going to go up here and deselect the quadrant. And if I deselect that, it won't allow it to pick that corner. And I want it to be that way for all my files. Sometimes it's nice to pick the corner of a quadrant of a circle, but most of the time it's a nuisance. Just like I kind of showed you, you have to be off to the side to pick the center of the hole, when you see that, it's basically this little plus sign with the circle. That's when you're always looking for visual cues. No matter what your CAD system is, you're looking for visual cues. But notice I'm not hovering in the middle of the circle to find it. I'm hovering on the outside. All right, so now I've chained those holes together, and it's going to roll me through the toolpath manager here. And we'll pick a tool. Mostly what we'll need is something to spot these holes with. So none of these are tools that I would use for that. So I'm going to click. If you deselect filter active, you'll see all the tools. And it takes a long time to go through all this. So I almost always use the filter and say, okay, I just want to look at spot drills. Deselect that. And then green check, and it will now just show me my spot drills that I have available. I'm going to pick a 3/8 spot, because I can go ahead and chamfer those 832 holes. Now you can do two things. You can double click here, or you can click the green check. I'm a pretty big double clicker. And it pops it into the tool manager here. And if you want to, I always like to double click on it again, and it'll allow you to set the parameters for that tool for this whole toolpath. Now, sometimes it does, and sometimes it doesn't. You have to watch it. I haven't figured out why it will sometimes and why it won't. But since we're running aluminum and high-speed steel tool, this 399 surface feet is probably fine. But I'm going to slow it down to 280. Which is twice what you'd run. You'd run about 140 on cold rolled steel. So for a feed rate, you can either go by your feed per tooth, 0.002. I don't know why it's telling me I got a 4-flute spot drill. That's dumb. Very few drills I've ever run across have 4-flute. All right, so that's gonna slow me down a little bit. So maybe I'll give it another half thou. All right, so the plunge rate and retract rate, none of that matters with drilling. So I'm just going to say, okay, that's all I want to do here. And notice how all my values change here. And your plunge rate and retract is invisible. It's not active. So I'm in the habit of just ignoring that part when I'm doing drills. It's good for end mills. Going on down the list here, this is pretty much benign information. If you're really big on your simulations, you can make sure all your links and things are set here. I generally ignore that. Here's where you can select, okay, is it going to be a tap? Are we doing a bore? Mostly what you're going to use are these four. So this would be your G81, which is just down and out, like we all feel sometimes. Chip break, this would be like your G73, where it goes deeper, deeper, deeper. And then this would be, the top one's going to be your like G83 pec drill. And then we have tap, and the Mastercam file I work on at Procon actually has sync tap on that as an option. So we're actually wanting to just spot drill. And then tool axis control does not apply here. None of this applies. Linking parameter does apply. So this is gonna determine whether you're G99 or G98. Here's your clearance. Usually select only at the start and end of the operation. And even though I use this every day, I still get a little confused with trying to make it do what I want. Sometimes it seems like it just isn't working right. But so 2-inch clearance. We want to retract. I like to set all these values to absolute unless I'm working on a different Z-plane. Then I'll set them to incremental. Because what this means is from where you selected your drill points, if you select incremental, that's where that value will go from the plane that you selected the points. So where incremental would come in handy is if, say, I had a drill way down in this pocket, I would set it to incremental like 0.1 on the retract if I just wanted to back up 100,000. So if you set it to absolute, it goes all the way back up to the top of the part, which actually you'd want, or else it'd crash into the board. But that's a whole other thing. So we're going to retract to 0.1. Top of stock, I'm in the habit of just clicking that, and I will just select the point where it's the top of my stock, and for some reason it's 7.5 thou. It should read 0. And I'm not quite. Sometimes I'll wait for that little green plus mark, and I guess my 0 plane must not be set quite right. So what I'll do here is I'll leave my depth set at 0 and go into my calculator and say this will tell you how deep or what diameter your spot drill is going to wind up at. And it knows what angle it is because you set it in your tool manager. Things running slow. Come on. Here is the tip angle right here. So some spot drills are 140 degrees. If you wanted to, if you had a 140-degree spot drill, you want to be sure and change your tip angle. Otherwise, when you go to calculate your diameter of your depth, it's going to make it way too deep. So I'm going to put that at 0. And since my holes that I'm chamfering are going to be at 832, I'm going to tell that to just kind of go out to what, like 0.160. I think 832. Well, let's go 180. And what we'll see is that that will make that Z minus 90 because it's a 45-degree angle or a 90-degree angle because it's all locked in up here because of where it's set in the tool manager. Leave this off. This will get you in trouble because if you leave your tip comp on, it's going to go that much deeper, thinking that you want it to break through. And the danger here is if you're doing a bunch of tool paths and then you do one with a tip comp, it remembers that for the next one, so you have to remember to deselect it. This we ignore. All this we ignore. Planes are all set on Op1, Op1, Op1. And we'll talk a little bit more about the plane manager when if we have time, when we start doing our next operation. Coolant on. So like these presets that you want to leave a certain way each time, you can make that, you can force that to be a default in the file manager here, and I'll show you that in a second. But so the rest of this we just kind of blast through because we're not using. So I'm going to green check. And right now, you can see it's doing a G99. It's doing a G81 with a G99 with Fanuc style programming. So this is the back plot. Watch it run. It's going to come through and spot all the holes. And it's also a good practice. Rather than going through all that all over again, I'm just going to use copy and paste because my next tool is going to drill these 6 holes, but it's not going to drill these 2. And since I selected them last, I can just delete them. So if I right-click right here, I can say copy, and right-click again and paste. You can also cut and paste. You can also drag and drop. I like doing the copy and paste because it seems like it lands a little better. So I obviously don't want to run that spot drill twice, so I'm just going to left click on the parameters and just change the values that I want that are going to be different. So we're going to need a new tool. And we'll just select the library tool and we'll go to our filter. Say now we want drills only. And the quickest way to, I wonder why it's not telling me what the diameter is. Usually I like to look at the diameter. Oh, here it is. I like to look at the diameter as a quicker way to find your drill than actually looking at the numbers. So what do we need? A number 29 drill, if I remember right, for that 832. And I'm going to go in and edit my tool parameters. Well, my computer's running slow. Next. This is where you change the tool number if you wanted to also. Surface feet, we'll go 280, which is double what we'd run for steel. And so that pops our RPM in for us. Now this might exceed the RPM of some machines. So if that were the case, you'd set it at the highest RPM that your machine can do. I think we got the Akumas at Procon only go up to like 8,000. So a light drill like that, you want a light chip load, so 0.001, maybe 4. And it's still going to feed at 22 inches a minute, which is cooking. But you are turning 8,000 RPM. Again, we leave the plunge and retract alone. Notice it names it all out for you, and I like to double check that it changed my values for me. So I like on taps, of all things, taps it will not change. So since we're drilling pretty deep in there, I'm just going to say PEC drill, which is our G83. And let's go on down the line. Okay, top stock's going to be say depth is going to be a little different. So sometimes you can zoom in, click the bottom of the hole, boom, you're in. Now here I'm going to tell it, yeah, let's go ahead and do a tip comp, but I'm going to make this 0, and then that will compensate. It'll drill at another 40 thousandths deep to compensate for the tip of the drill. So you get kind of spoiled with this sometimes, and you kind of forget about how to calculate things. Unless you teach it, and then you remember quite well because you teach it over and over again. So, all right, so then that's going to leave that dirty because we copied and pasted it. So it's kind of its own. We have to regenerate to make it a clean operation. So as you see, it's the only one selected. We run this. And if you get used to doing this, it's considerably faster and more accurate than programming by hand. See, I don't want those 2 holes. So I'm going to go back and edit the parameters by left click on the parameter. And up here on toolpath type, here's where my point geometry is. So if you click the existing, it'll show you where they are and pop this box back up. Now these are my last 2, and as I click them, you'll see they turn blue. So it shows you which one they are. And notice the little red icon, right button icon. Delete. Delete that one. Of course, it deleted the wrong one. That's weird. Must be the other side. This is why, that's why I usually just end up deleting them all. And I just pick the wrong ones for some reason. Delete. I'm just going to delete all and reselect them, I guess. All right, so just going to pick the drills I want. That one. Kind of counterintuitive on the which ones to pick, in my opinion, because I'm picking the wrong ones. All right, so now it's going to reselect those. Green check on this. And regenerate. And now it's just going to pick these holes. So on the tap cycle, it's going to be super easy. I'm just going to copy and paste here. And it'll put it in front of the arrow and leave the green check. So you know which one it is. And we'll turn this into a tap. So we're going to select the library tool. Man, this thing's running slow. There's no taps in this library because it's only drills. So we'll go back to filter and right-handed tap. It seems like the long way, but once you get used to doing it, it goes a little faster. So 832. And we'll edit these values. Boy. Starting to think my computer has a virus because it's like I'm not used to this bar being black right here. It's usually white. I don't know what happened different. I'm gonna run Spybot here tonight after class. It's probably a huge virus. Huh?
Yeah, it's not coronavirus.
Yeah, I think it's a Yuja virus is what it is. Okay, I'm gonna leave these tools alone. Okay, so this is 1600 RPM. That's way too fast. So I'm gonna put this down about 300 and see where that lands. So I think Jeremiah was asking a question last week about feed rates. And what does Akuma's only go to 2 decimal places when it posts? So what I like to do, I said, okay, that's 9.375. I'm going to take my feed rate, which is pretty much the thread pitch, and I'm going to divide that by the inches, like 9 inches per minute, and it should give me the RPM. So if I say 9 inches a minute divided by 0.03125, it's going to be 288 RPM to make it a perfect 9 inches a minute. I've just been doing that because of the Akumas and the rigid tapping, and it just makes a more accurate feed rate. Now the other thing to do is I think there's an M code or a G code that will put it in inches. It's a G code that will put it in inches per rev, and I just don't know what that is. Okay, so now all we got to change is our cut parameters is now a tap cycle, and we want to be careful. Oh, one thing I wanted to double check. See how it did not change my spindle speed and feed even though I changed it up here? That's annoying, but that's got me in trouble more than once. 288, 9 inches a minute. So you have, for some reason with taps, you have to manually change that. There's probably an answer somewhere on the internet about that. So not one thing I like about copying and pasting my tap cycles with my drill cycles is I know that this is the depth of my drill cycle. I can just say plus 0.150. And if you come down here and hit apply, it'll add that to the value. And so now you know you're not going deeper than the drill. Now this is where you get in trouble though if you forget to turn off your tip comp, then it will compensate and go back another however much that is. So just turn that off, cooling on, and we're good to go. So it's going to leave that operation dirty because you copied it. If you created a brand new operation, it wouldn't. So if I want to watch this whole thing run, first I'm going to Control S, save. Just click this toolpath group bar and it'll turn them all on. And so we can go into backplot, and since we don't have a real mill to watch, let me rewind that. So to also get an idea of how long this thing's running, if I expand my backplot, come down here to information, it'll tell me that my cycle time is 6 minutes. Now how accurate that is depends a lot on your machine. Got a ref, finish pass. That's pretty much as far as we've got this part programmed. So tonight we're going to program this, rough and finish this out. We're going to counterbore these, and then we'll see what kind of time we've got and plot it out in Mastercam. Now, one more thing I want to talk about a little bit here is the whole posting thing. So these are all selected, and to post it, turn this into a readable code, you have to left click on this little G1, and I've got it set to overwrite, and that way I don't have to. If you have it set to ask, you'll have to save it to a file, and I just want to look at it. Right now, it's set to a generic Akuma 4-axis mill post, and I wanted to show you guys kind of what that looks like, because we were supposed to. Out of range. Oh, the tool number's out of range. We're supposed to be able to play with some Akuma mills this semester, and that didn't happen. I doubt they'll even be. I'm pretty sure they won't be set up at the end of the semester. But just kind of some differences between Akuma and what we're used to looking at. You'll see a lot of this is the same, the G40, G20. This H0, that's for a fourth axis, just ignore that. G15, let's see. So this G56H23, that is like our G43. So notice it's calling it tool 23. When we say G43, it says G56. This G15H0, that would be like our G54. So it'll have, usually what I'm used to seeing is a G15P1, G15P2, G15P3. Those are your work offsets. So you can see it's pretty much, everything else is pretty much the same. With the exception of drill cycles. This M54 is what designates between G98 and G99. So there will always be a Z value before your drill cycle. And if it's M55, it will go back to this Z value. If it's M54, it will do the R point. So Akuma doesn't use G98 and G99. So really, those are the only real differences. It's putting these A values in this for fourth axis, so ignore that. G84, our Akuma has used a G284. It didn't give me that option. It's a sync tap option. Other than that, the G56H1, that's our G43. The two differences. The one thing I'm used to seeing different here, and I don't know why it's posting it different, is this G15H0. It's usually a P value, or a P1, G15P2. So everything else is just kind of, this is a helical. See all this G1 noise here? So it does one circle, and then it goes and does all these little very small moves. The reason it's doing that is because last week I did not go in and turn on, let's see, it might just be this post actually. Cut parameters, linearize arcs, rough and finish. Output arc moves for yeah, so that's the post doing that. So let's go ahead and I'll show you two different other options. So if you go into files, this is also where you would change your operation default. So if I wanted to say I wanted my coolant to be on all the time, nope. You hit the exclamation point, and it's going to pop up all your available tool paths. And what you can do is open these up like 2D tool paths. Say I want it every time I turn on a drill, I want my coolant to be on. Can't find the drill for some reason. Wireframe. Let's just do pocket, for example. I don't want to be hunting around. Just go in there, and it will open up the parameters for contouring. And if I always wanted that to be set to where, I can set it in here, X out or green check, and now it's going to change the whole configuration file in Mastercam for that. From now on, every time I open Mastercam, that will be set to where. So at work, I've gone through and made it standardize a lot of my toolpaths so I don't have to think as much. But all right, let's show you. I wanted to show you a Heidenhain post while we're goofing around here, or while I'm goofing around. So we're going to replace. This allows you to pick a different machine group. I happen to have machine groups from my last versions of Mastercam, so you may have difficulty doing this. But let's just pick this generic Heidenhain 3-axis mill. I'll double click on it, and it goes through. You can see it going through and really jazzing everything up here. It's processing everything through the language of a Heidenhain. So when I post this, generic Heidenhain post is in there. And I have to switch it to override again because I changed my processor. Going to open it up, and we'll get a little view into what a Heidenhain looks like. I've had the privilege of working with Heidenhain, but you'll see that the code is real different. It does the same thing. This will cut the exact same part as the other code. All right. Notice all these L values. There's no G codes. Every move has to have an L before it. Notice this F max. That means linear move at maximum feed rate. So everything's either a circle move or a line move. Notice these drill cycles. It's almost like conversational. So it calls out a lot of these cycle definitions, and then each of these Q values is how it controls the depth of the hole. So your setup clearance, 0.1 above the part, depth minus 0.090, so that's our spot drill. Feed rate for plunging, notice it's 143. That means 14.3 inches a minute. It always has a decimal to the next to the last value. Plunging depth of 0.1, dwell time 0, because we're not wanting it to dwell. The surface coordinate means where it's starting from. Because remember we had that 0.0075, it should really be 0. So all these values then get plugged into the following holes. So these are the rest of the holes. One thing I really wanted to point out, so you can see it's really not that hard to read. These are circle moves. So it's cutter compensation on, I believe, DR plus. So this is turning on your cutter comps. So it'll be your circle center point, and then your circle center point, IPA 180. I'm not going to pretend to understand this language thoroughly, but this is what our 5-axis reads, and it actually uses plane spatial moves and things like that. It's pretty crazy, but you can kind of see what a valuable tool Mastercam is. I can say, well, I want to run this on the Heidenhain today. So then you just pop in the different post processor and you're off to the races. You don't have to think about it. You're probably not going to scrap anything because it is quite accurate as far as, what it will output. It's pretty reliable. I've had a couple crashes that I did not anticipate, and it was mostly my fault for not realizing there was extra material on a part or something. But yeah, it's pretty cool. So let's talk about the program. A few of you've got this done, and I've actually mistakenly gave full credit for it because we're not quite done with it yet, but pretty close. Jeremiah brought up one move that was bad, which is this right here. This was actually a circular interpolation. So there needs to be a G, for my caps lock on, a G1 here. Or else it'll still think it's trying to cut circles. So I wanted to just a couple of you guys had questions about the J's. I wanted to kind of go over that a little bit because I don't think we're going to cut a lot more circles. there's no, I don't think there's a ton of circular interpolation on nothing like this where you'll be helical interpolating or anything like that, but it's a lot like the first homework where we had, like cutting quadrants and things like that. So that would be something you'll want to review. But how this works, I'll just kind of explain it again, is up here, obviously we're positioning the end mill to the right hole, x562, y minus 0.990. We're calling up the G43H6, which if you remember, it's G50. This G43 is actually G56 in Akuma land. So very subtle differences there. Putting the Z an inch above the part, which will be a reliable place for it to land at while we're calling up its tool length offset. And positioning 100 thousandths above the part in a feed rate of 50 inches a minute. So the first thing we're doing after that is we're ramping in an incremental of the Y and Z move to the very top of the hole. Let me pull out the programming workbook. Nope. Actually, want to leave that up. So let's go to, had almost everything open on one. Make a new tab. So the spring housing. There it is. So we're ramping up to the top of this bore, and we're going to be pretty much just scratching the surface of the part at this point. And because we're in an incremental, it will really be at Z0. If we didn't have this 91 in here, this G91, it would be 100 thousandths into the part right now. But I just wanted it to be at Z0 because that way when we do this loop, it'll be a little bit easier to calculate how many loops we're actually going to do. So this next line, I'm thinking it's going to be a G, no spoiler here for those of you that haven't done this yet, but since we're wanting to cut counterclockwise so we can climb mill, it's going to be a G3. So G3 does nothing more than say, okay, we're going to start cutting counterclockwise. That's all that says. The J minus, this value right here, says, okay, from the start point of this arc to the center of the arc, from and to is the important word here because that's what determines if it's going to be minus or plus. So if I start here, my center's here, it's J minus. If I start at the bottom and my center's up here, it's actually going to be a J plus because from the start point to the center is a plus direction. So always remember I, J, and K are always incremental. Now if we were going to do start our radius or arc over here, and the circle, the center point is to the left, it would be an I minus 0.521. If we were on this side of the circle, it would be I plus. So from the start point of your radius that you're cutting to the center of the circle is what dictates your I for X, J for Y, and so that's all that's telling it right there. Oops. That's not what I wanted to do. That's all it's telling it right there. Now, the Z move is going to incrementally move Z minus 50 thousandths. And the L21 says, hey, do this 21 times. Now, the reason it goes all the way back to the top of the circle is because you didn't give it another X or Y value. So it assumes that X and Y are 0. So you could do the same thing by saying X0, Y0, J minus 0.521. you don't need to put that in there because it already knows, it assumes that. So it's just like if you're, having a drill cycle up here and you've got your X and Y position up here, there's no need to actually put that value in this line down here. So that's pretty much how that works. Let's see. Does anyone have any questions about that?
So you're using a G3 instead of a 13. You're just doing circle, right?
Yeah, G13 is more of a pocket milling cycle, I think.
Yeah.
And I mean, we do that one homework assignment with the G13, but I don't really elaborate on it. In the past, where I've had people program the pockets, I've had people use the G13 cycle, and that's fine. The reason I don't do too much with it is because it's really specific to Haws, and I never use it. So
Oh, okay.
circles are pretty easy to cut, and I have for some reason the that circle toolpath just does not, that pocket milling just does not stick with me. So then I got to remember what all the I and K and J means, because it doesn't mean, like the center of an arc or anything like that. So I just kind of stick with and I go one step further. If I know I'm going to cut a full circle, I'll just move, and if possible, I'll just move up in Y and do a J minus, and then I know it's going to cut whatever this value is, it's going to cut the full circle. So that's a good question, because that pocket milling exercise we did definitely used G13, but there's so many variables to try to remember. So I guess that's why I stay away from that.
That's what I was stuck on. I was stuck on using pocket milling for that.
Okay, so did that answer your question?
Yeah, I think so. I just got to look at that. Okay, you covered the J negative value because you hovered above the center point of the circle, or the drill that the hole that you drilled, right?
And this L21 says do this line 21 times. So it'd be 0.050 times 21.
Okay.
Times 21 is going to be 1.050, which is our depth. Is the depth of our part. It would be fun to set this up and run that just to watch it go, because you can create, it's a pretty powerful line to program, because it, does a lot with just one line.
Okay, yeah, the negative makes sense to me now, because in the line above it where it's you moved it to positive 0.521. So then, okay, that makes sense.
All right, so I'm going to, this program is actually done, except we didn't give it an M30. Pretty sure it's done. And then we want a percent key right there, and I'm going to control set. What we probably need to do to finish this up is we need to program this step and counterbore these holes, and then we need to program the back and plug in these two holes. So this is what's going to hold the retention bar on it and actually hold it in the lathe. So without further ado, I'm going to let's see, so save that. So if you haven't got this done yet, that'd be a good thing to wrap up this week. I'm gonna go to File, New, or I could have done Control N. And I'm gonna start with a percent sign, Shift percent. This will be spring housing. Oops. O. I better pull another program out here so I don't leave my stuff out. So while I'm doing that, if you're just joining, if you joined in late, we will be here next week. A thing that I was going to got canceled due to coronavirus, and so we'll have live class again. And then the following week will be just the final. I'm pretty sure about that. So I'm going to send out an email, an announcement with some lab opportunities that are after the semester that won't be worth any points. I don't want to pressure anyone into, having to go down to the school if you're concerned about the coronavirus. So we will wrap up the class off campus, but I will make, if possible, they're still working on the details, making available some lab time for folks who want some more hands-on experience. We'll try to set up 1 week of that. Okay, so let's see. Every program starts with the letter O, and if I say letter O number 3 would be the same as saying O00003. So 5 digits. Some machines take 4 digits. Just depends on the machine. In fact, some Haas machines take 4 digits. Some take 5. So you have to be, willing to roll with all kinds of different little nuances between machine tools. I remember I went to work, I forget where I was working. I've done a lot of part-time work in a lot of different places around town. And I remember complaining, I remember it was at Unitech. And I was like, man, this Akuma seems so backwards, kind of whining about it. And one of the guys goes, well, it's not that it's backwards, it's just that you're not used to it. I'm like, well, touche. Yeah. The last time I complained about a machine tool being backwards, realize how silly that sound is. Like, well, you're just not willing to learn it. This will be spring housing last. Or nope, second. Actually, I have 2 more ops. Second. And however you want to do that. All right. We'll probably just kind of see. We're going to hold this. It's good. It's good to put in your program some descriptive how you're going to hold it, where your X and Y positions are. I'm going to get this I like having the sunshine in, but I don't like it blaring me in the side of the eyes here. All right, so this thing's going to be, remember, we've already cut around it. We've cut around the outside, but we've still got material left from here over. And we're not going to get to cut that off until we do the 3rd op. So I'm trying to think, where's the best place to take our X and Y readings, So we're dimensioned from this side. This is the part that wasn't dimensioned from here to here. So it's a good thing that I didn't close the master cam out yet. Because we don't know how deep this pocket is from here to here. I think that's yeah, we know the 890, but we don't know from there to there. So I'm going to get my little Spider-Man measurement thing out here. And when something's got all these fancy chamfers on it, you have to be kind of careful. In fact, I always ask our SolidWorks engineer to not put chamfers on stuff because it makes it harder to program. With the exception of sometimes holes that have chamfers on them. That can be helpful. Okay, so from here, you can see how the chamfer kind of gets in my way of finding the exact numbers that I'm looking for. But that is 0.8. And I know that because if I hit top, this is my Z direct, that is in Z on this plane. Now notice the line's crooked. Doesn't matter. The 3D line is 1/1000th longer because it's at an angle. But down here will always give you the default 90-degree dimension. Because it's like, yeah, well, why would you want to know what it is from here to here? But just in case you did, that's this. That also gives you your X and Y positions. So you can see that from the green point starts at 1.8245. Red point ends at 1.0245. So you could subtract those two together and still get the 800 thousandths if you wanted to be sure. So now that we know that, we can start programming this. Once I get to moving models around with Mastercam, I always want to do it with my drawings too, flip them around. So to give you a visual of what kind of strategy I'm going to use here, be easier just to kind of show you. So everything so far we've done in this top view, but we don't want this view anymore because that's going to be, everything's going to be on a different plane now. So what I'm going to do, I'm going to create a new view sheet by just clicking on this plus sign, and I'm going to rename it Op2. This is how I do it at work, and this is how I was trained to do it for my Mastercam certification. So the idea here is you just grab this, once it starts glowing, you can left click on it. You can grab it over and make your X, Y, and Z position in a new spot. So I think I'm going to make it, okay, notice we can't hook onto the corner here because some engineer made all these fancy chamfers on there. So the way to get around that is you go into your stock setup and you tell it you want to create a bounding box around this thing. Pick the part and end selection, but before you X out of this, say I want corner points. And what that'll do is it'll put corner points around your stock. See that? So now I can select those points. So if I wanted this to be my 0, I would have an exact point to pick from. So we'll just select that. I don't want to see the stock in my display because what it does is it leaves red dotted lines on there, and I don't want to see those. But I do want to see the points. All right, so now I'm going to go in here and pick my new 0. Notice I don't have a bookmark here yet because I don't have a point. So I'm going to zoom in here so I don't accidentally catch the corner of the chamfer. I want to make sure I'm not on the chamfer because I've got myself in trouble with that more than once. Now I'm going to rename this Op2. And make sure this isn't flashing when you go ahead and double click because it'll erase it. So it says, okay, double click to accept the results. And okay, so now I've got Op2, and notice my grid is now has not changed yet. So it means it's not on that plane. My plane manager, I'm going to select Op2 and it whips around. Oh, it must not be where I want. So I'm going to edit. Yeah, I didn't move my Z around, so it left it where it was. I want X to go this way. X should point in the plus direction, but Z needs to point towards your tool. So I'm looking at my blue box here, and I'm pretty close to 90 degrees, so I'm going to just type in 90, enter, enter. Now, green check, and when I hit Op2, it changes my view. So everything, all the programming I do will be based on this op. Now, so I can switch back and forth seamlessly between these two tabs, I'm going to right click. I'm going to say save view sheet bookmarks. So Op1, Op2, and I can create toolpaths all over this part without affecting the other toolpath just by doing that. So to separate these two, I'm going to come up to machine group and right click and then go down to groups. And I don't want a new machine group because I'm on the same machine. I want a new toolpath group. If you pick a new machine group, it'll allow you to have a whole different stock setup and even a whole different part, really. But I don't want that like when I run a verify, I want to watch it cut the whole part. So it's just going to be a new machine group. And I might just name this Op2. And I like to have my files organized because invariably by the time a machinist gets a hold of it, there's, potential problems with the setup, or they want something different. They'll say, hey, you weren't thinking clearly when you did this. Actually, I should have right clicked in the op, but see, now it connected it to the machine tool. So you got options anyway. So if my file's organized, I can easily go back in there and say, okay, I've got op1 here, op1's here, op2's here, here's op2. Okay, so I'm just going to show you what I'm planning on doing with my end mill. And we're going to pick a contour. And I'm just going to pick a solid line across here. Since it's a solid, I got to pick from the solid menu. If it's wireframe, we pick from wireframe, but there's no wireframe geometry here because nothing's lighting up. All right, so now with the solid thing selected, everything's lighting up. The idea is to pick all your tool paths without creating geometry as much as you can. Sometimes you can't avoid it, but all right, so this is bad because it's trying to select this whole thing. All right, I don't want that. Deselect all, and it'll say, are you sure? That's why I pushed the button, man. So we'll pick this partial chain because I just want to chain this one line. We're going to take multi-passes across the front here until we get to the end. So the arrow's pointing to the left. Cutter will be climb cutting across. And you just need to pick that one line because the multi-passes will take care of everything else. Not sure why I did that. Toolpath. For some reason, I must have just X'd out of it instead of agreeing. You wouldn't know I was doing this all day long today. So green check. That took it that time. So you'll see my chain geometry. I have one chain. We're going to pick a tool, and since we did this in under a new machine group, we lost all our tool files. In fact, I might redo this, and we'll say let's just delete this. So I'll show you the difference. Now I want to delete this. It can be hard to get rid of. Just hit the delete button. There we go. So I got rid of that because I really want my op1 to be tied to this same machine group. So I need to right click in op1 and say groups, new machine group, mill. So it did the same thing to me. Huh. Oh, you know what? I did a machine group. I don't want a machine group. I want a toolpath group. Sorry. Delete. You're like, man, he's a programmer. I'm going to say toolpath, new toolpath group appeared. I must have done something weird the last time. I just want a toolpath group. Okay. The idea is I want these next to each other. I want both of these toolpath groups nested in the machine group. So this will be op2. You can see where you right click makes a difference on what shows up where. All right, so I'm going to go back, no toolpaths, contour. That was worth it. Bugs me when things aren't right. Okay. Now, you could have a different opinion of how you set up your files. There's just lots of different ways to do it. So I'm back to where I was climb cutting. Green check. The nice thing about being in the same group here is I can pick from my same tool list that I've already created. But once you get outside of this machine group, all this goes away. I'll go to flat bottom mill, flat bottom end mills, retain all of my surface feats and things. Don't care about this. We're going to take a maximum rough step of everything but 10 thou. So you could say, 1 inch. All right. It'll take up to where you want your finish pass. So if I say 0.020, because I want a nice finish on the bottom, one finish cut at 0.020. I don't want to keep the tool down because I want it to rapid and just cut one direction. Lead in, lead out. I'm going to turn off my radius. So I really just want it to lead in with a straight line. And we'll see what that looks like. First cut only. Turn off the breakthrough. That's the same as the drill if you wanted to add it to the depth. We're going to take, let's say, 6 passes at 150 thou and 1 pass at 10 and no spring passes. For top of stock, we'll just go ahead and pick this again. It's best to just pick the model. That way you don't have to think about it. It's like watching Saturday morning cartoons. 887. Oh, because we didn't know this stuff. This is the 800. Okay, so that's all done. Blah, blah, blah. This is where, if you don't check this, it's going to output a bunch of little X and Y moves. And I always just move the smoother over. This makes the optimum size file. We're not cutting arcs in X, Z, or Y, Z, so I'll leave those blank. Notice how our plane now is an Op2, Op2, Op2. If you wanted to change this, you say, no, I really wanted to be an Op1. And that would change it here. And then if you want to change the rest of them, but we don't want to do that because that's Op1. So we'll go back to Op2. All this is about is where your code is going to output from. Coolant on. And let's see what happens. Nothing. Awesome. So when we go back to run the back plot, we'll see that the end mill is probably going to crash because see how it's hitting the edge. And it's not rapiding back. It's not rapiding up and over. All right, so to fix this, we're going to increase, go to lead in, lead out, adjust the start of the contour by extending it, maybe at least half the cutter. What was that, 3/4? Let's go 0.5. Just the end of the contour. And what's my linking? See, no clearance. Retract, 0.250. That needs to be like, let's see, I guess that should have, for 0.1, feed plane, clearance. 1 point. All right, that should fix it. And that way you have a good visual of what we're actually going to be programming here. The sun is shining on my computer and I'm seeing all the dust on it. All right, so that made it to where it's not going to crash, but it's still not rapiding off the part. See that? It's just crashing right into it. Those are all linear moves. So it's like sometimes something must be, keep tool down must be selected. First path only. Linking parameters, multi-passes. Keep tool down. There we go. Regen. And now I think it's going to do what we want. Wrap it over. So this is what we're going to program. What I want to see is, so we chained that one line, and by multi-passes, we've got it to actually machine more of a 3D feature. So now it's going to go through and take one more round of these and actually, but that, I don't like that step over. So the nice thing about it is we can kind of say, well, that's not going to really work too great. Let's go 0.2 and only 5 passes. Regenerate. And then I promise you we'll program this by hand. Whew. Lots of dust. Well, that's no good. 4 passes. Nice thing about this is you don't really have to think too hard because you can visualize it. Now we're going to win. Now it's kind of a pain because we really want to take that last swipe probably in one pass, so we wouldn't have to sit there and go over and over and over it. You pretty much have to create a second toolpath if you want to do that because it's Mastercam's big on looping stuff. So anyway, that's what it's going to do. The cool thing about this is if you wanted to watch both ops run, you can click op 1, hit the shift key, click op 2. We go into verify. And you can watch everything. Once you have a part all the way done, I always watch the whole thing run and verify. So it's drilling, drilling, drilling. I don't think we forgot to program the half-inch end mill, but or the half-inch, 3/4 inch drill, but we'll skip that for time's sake. Kind of reminds me of a dog drinking water or something. And then it should flop around the other side here. Mill this out. So the cool thing about this is you can see your part cutting all the way through the process. So we can see that our bores are past the bottom of that step like they're supposed to be. Everything's good. So that's going to be our strategy for that. I'm going to save this. All right, so now that we've got it all automated like program, let's program it manually. So we're going to hold in vice by probably our 1.832 dimension, or let's see, this 1.690 dimension. So hold vice. 1.690. And it's really hard to describe sometimes just looking at it. We're going to say 1.832 dimension should align with z-axis. (1.832 dimension align with z-axis). All right. We got to pick our 0 points, and why not make them the same as our Mastercam file? So x 0 is left of finished part. Y0 is back of part. And Z0, back of finished part. I like to say finished part because there's no mistake of finished part. There's no mistake where Y should be, or any of your positions if you go off the finished part. So Z is top of, I'm getting a little ahead of myself here, finished part. Typing is not my strong suit. I haven't saved this yet, so I'm going to say File, Save, and it's going to prompt me to save it. This is our S20 CNC mill, and I'll just say, here, I'll just click on this, and I'll put most of that in there for me, what they opt to. Yes, I do have my phone today. Anybody you have a question? I haven't checked in a while. Yes, we are going to chamfer the edges. We definitely will. Or you guys probably will. We'll get the thing started. We'll see. How can you hold it by 169 and still drill and counter the holes? That's a good question. If I'm holding it by the 1690 in the vise, oh, you're right. We want to hold it by the 1.832. Thank you for catching me on that. So it should be hold in vise by 1.832. And 1.690 dimension should align with z-axis. Let's double check that. An example of me trying to talk and think at the same time. So yeah, we're coming at it with z this way. Unless we had some kind of a fancy 5-axis or something, which we're not. So we want to hold it by the 1.832 z-axis. And we also should probably mention that the bores should be to the fixed jaw, because this is going to be the front of the part. Thanks for catching that. Helps me know that you guys are not just sleeping. Not sleeping. Okay, so enter bores to fixed jaw. I've got myself in trouble a time or two by saying front of the machine or back of the machine, because front of the machine to one person is the back of the machine to the other person. So you know that fixed jaw is going to be, and another problem. You know where that fixed jaw is. It's more descriptive and less left in the imagination. So the first thing we need to do is we need to roll out some safe start lines, and I'll probably just do this week, and so that way we can review the codes. So G0 is rapid, G90 for absolute. Now, if you get into lathe class, this is something you will never see on a CNC lathe, is G90, because it's U, V, and W for incremental on the lathe. Okay. So G90, G54 puts it in the correct work offset. G80 is one of those antiquated codes that I like to put in there anyway, just to give you something to talk about. G20 would be inch input. If you were programming this in metric, you could just simply give it a G21. Some shops are vehemently opposed to using G21, so you have to convert everything. I know I had some people that work at Ford, and they always use G21 because they do everything in metric. But the default power up on the Haas machines down at this campus is G20. I'm sure you can change that in the settings. And then like a G17, it's in XY plane. Remember, XY for G17, ZX for G18, and YZ for G19. All right, first tool is probably going to be probably want to face this thing. Now, if you remember right from last week, we were trying to just dust the back of this. So when we went around it. So what's going to be tricky here is when you lay it on its back side, some of this is not going to be cut. In the lab, we would not be able to use two parallels under the part because of our previously milled step. Yes, that's exactly what I'm talking about right now. If you think about it, we still have a step right here, and we also have a step across the back. So this is all going to be taken care of. You know, technically, it probably would have been smart, hindsight, just to mill around these three edges and leave this flat. But you know what they say about hindsight. we've already cut it to this point, so we'll have to put a parallel against the fixed jaw. And one thing that's smart to do would be to put a block between the movable jaw parallel and the other side of this parallel, so that way it would hold it flat against there. A lot of times at Democo, we used to like put springs between our parallels, and that would hold the parallel against the vice jaws and not allow chips to get down in there and cause all kinds of problems. And because everybody knows that if you get a chip under your parallel, you're going to start scrapping parts, because even a piece of dust really will scrap apart. So yeah, we're going to have like a parallel here and then one right here, because there's going to be a lip right there that will mill off when we do this. Okay, so we want to probably leave, and it's going to be up to the setup person to do that, because although this is finished, so we don't need to face it. We don't need to face mill it. So we just pull out our end mill and start hacking at this step. This is a finished surface, and so from here to here has got to be 890. Makes sense? Check for any questions. None so far. Awesome. So we are firing on all 8. Okay, I don't have a cheat sheet at this point, so I'm just kind of, I think I'll probably tile my screen so we can see the part and the program at the same time. Side by side. That really muddied the water. That one, love doing that. Kind of helps me get my pent up aggression out. Just slamming that window into the side there. I always like to put, if you do this at home, I always like to put my program on this side because it gives me more room over here to look at my drawing. Okay, so our first tool is going to be T1, not I, T1 M6. And we're just going to call this, well, like a 3/4 finish mill. It's funny because back when I worked at Democa, I used to use hog mills all the time, and now we don't. So I just can't hardly fathom to pull one out. We just use high-speed, like Whittier cutters that are kind of roughing and finishing mill. I sat through an hour and 10-minute Kenmetal webinar today that seemed really, really long because it was the Titan of CNC. That guy kind of drives me nuts. But they're just like, the whole webinar is like, oh man, we just need to really stay in this great industry because we're so great, because we're machinists, and I'm like, blah, 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 blah. They talked about 5-flute cutters though, and that was a relevant thing because 5-flute cutters are typically considered good for roughing and finishing, because if you think about it, you don't have parallel flute engagement. So just the fact that you have an odd number of flutes makes them good for roughing. See who's all here tonight. Most everybody's here tonight. Awesome. We only got a couple more classes. I will say I'm going to miss doing the Thursday night computer class, but I way more prefer being at school. So hopefully next year we'll get to be back. All right, let me get out of that little editorial mode. So this little arrow, it's convenient, but it's really for something else. But this is our X and Y 0 and Z. So we're going to, just like in the Mastercam file, I want to start on the right side of the part, cut to the left. We're at 2.630, and I'm probably going to draw a little my little thing here so I don't spend a lot of time recalculating. So I'm basically going to map out my points. From this 0, we got 0, and then we got 2.630 to this spot. So we want to know what our clearance plane is. So I'm just going to make a little calculation. Oh, I hate that. It's got to be a certain size. All right, escape 2.630 plus. Since this is all machined, here isn't, but so we're going to have to kind of be careful here. We got some extra material sticking out. This is all machined, but we're not cutting this. So it wouldn't be any more than 2.750 because that's the size of our material. I'm going to say for a 3/8 cutter, we could be a solid 1/8 of an inch away. So we'll go 2.630 plus, let's go 0.6, just to be real safe. So clearance plane, I'm going to write down on my sheet, clearance plane would be 3.230. Clear, and I just abbreviate CLR. I know it's kind of a cleaner, but this is obviously going to be X0, so we don't worry about it. Clearance plane for it will be X minus 0.5. And since we're Y0 here, remember we're 800 thousandths deep. Our overall is 1.832. So that means from here to here is 1.032, right? So this would be, by itself, this is y minus 1.032. 32, and then you add 3/8 of an inch onto it. Or we could just use our cutter comps and tell it. Cutter comps is probably better because that way if it comes out off, we can fix it with just moving the comps. So we'll just make that, leave that y minus 1.032. Everybody see where I got that? This is 800. The overall is 1.832. So from, if this is 800, that means from here to here is 1.032. I can double check that. Although I've found my model to not be 100% accurate with my drawing for some reason. Typical. So let's measure distance from this corner point to here, 1.032. So I was right about one thing today. Maybe I should quit while I'm still ahead, right? Hey. Okay. We'll just use comps. The problem is with the comps, you almost have to turn them on and off with each pass, which is going to be a huge pain. Plus, we want to cut chamfers on this. So what we'll probably do is take a couple swipes across with no comps, and then we'll come in here last thing and turn the comps on and take a cut and cut the angles, which you would have to, if you're going to do that in Mastercam, you would have to create 2 completely different tool paths, which wouldn't take much, but that's how you'd have to do it. So, okay. This 1.032, since we're not using comps until we get there, I'm just going to add 1.032 plus 0.375. So this with the radius of the cutter is going to be 1.407. 1 minus 1.407. So we'll probably take it down to about y minus 1.420, farther away from 0. And then we'll wrap it over here, and then we'll just turn on the comps, and we'll swipe across there, poke these holes in there, and then we'll be done. Okay. Oh, there I go, trying to move the, wobble the 2D drawing again. All right, so that's really not what I wanted. All right, so we're just going to say G0 G90, G54, kind of a mini safe start line. To position X and Y, and we're going to turn the RPM on. Kind of the same format for every single tool. So remember, our clearance was X minus 3.230. I wrote that down. I kind of abandoned the idea of trying to use any kind of whiteboard because it just doesn't work. Y, so this part, 1.832. So since we're not using comps, we'd have to say 1.832 plus our half of our cutter would be Y minus 2.207 to miss it. But we want to take about a 200,000 swipe right here. So we'll just say Y minus 2.007. Forgot my space. All right. So what we'll probably do, and this might challenge some of you guys, is we'll rough it all the way down to rough this out. And then your guys' job will be to come in here off the side, turn the comps on, cut the angle, come over to the other side, cut the angle, and comp out. Wasn't X0 the left side of the part? Yes, this is X0, right? So I'm at X minus 3. Oh, I'm sorry. You're right. X plus 3.230. That would have put me clear over here. Thank you for catching that joke. By the way, you can always text me questions too, like Joe's doing, and then if you have something that you're seeing that I'm doing wrong, which is great, because glad you're catching that stuff. All right. Oops, that's another thing I'm doing wrong. There we go. Okay. We're going to go about S. Just quick little review of feeds and speeds. If we have 3.820 times, we'll go double the 140 to 280 surface feet, enter. Divide that by 0.750, and they're around about 1400 RPM, which looks pretty good to me. And M3. If you didn't have a semi-roughing cutter, if you try to do this with a finishing end mill, it would probably squall pretty bad. Just so you know. All right, G43. Turn on the tool length offset 481. Z 1 inch above the part, and turn on the coolant. And this is a new habit I got in. I didn't ever used to do this, but now that I do it all the time, I'll say G1, Z minus, and we probably want to stay about 20 thousandths off the floor because we don't want, oops, there I go again. We don't want to be having a bunch of rough marks going across here. I think we'll take one finish pass here, and then for our finish pass, we'll just take 2 swipes at it. All right, so this is going to be what? Z minus 1.890, Z minus 0.890 minus 0.020. So it'd be Z minus 0.870. 870. F, I don't know, 50 inches a minute. Wouldn't be too bad of a production delay. Let's save this hard work. Now it's time to rock and roll. We're already in G1 mode. So we can just rip across here. We're positioned in Z. So we're going to rip across here to X minus 0.5. F. Now we're talking pips per rev now. So if we wanted to take 3 thousandths per flute per rev, it would be 1400 times 0.003 times 4 flutes. That's 16 inches a minute. I'm going to say that's going to be a little bit fast just from experience. Let's go 12.2. Just a little faster. All right. So now we can just say G0, Z.1. Yeah, used to not putting spaces in there. You don't have to put spaces in here because the machine tool will do it. The only reason I'm doing it is to make it a little bit easier to read. Okay. Then we're going to zip back over to our X clearance. So I just copy and paste this. Copy, paste. But this is going to be Y minus 2.007 minus 0.2 because we're getting closer to Y0. So it'd be Y minus 1.807, I'm pretty sure. No better than doing math in my head this time of day, or ever. Minus 0.2. So yeah, Y minus 1.807. Okay, so remember each line needs to execute. It's going to execute one line at a time. So you think of each movement being one line. Now we're going to go G1, Z minus 0.870, F50. This is optional. You could wrap it down if you wanted. 0.870. And that's that 890 minus the 20 for the cleanup cut. F50 point. And then we're going to come across the back of it. Say X minus 0.5, F12.2. Now, I don't know how much more we got to go here. I forgot to write down what my clearance number was. It was 1.832, so it's 1.032 plus 0.375 plus 0.375. It's going to be 1.407. Oh, I did write that down. Finish mill. I just wasn't sure what it was. So we got a couple more passes to do here. So what I'm going to do is I'm going to copy and paste this just to save a little time. Paste. And I think we'll need one more. Paste. So I'm going to put a couple lines down here to control save. .2, so this was the first one, 2.1, Y minus 1.807, so this would be Y minus 1.607. And then Y minus 1.407 is actually going to be our finish pass. So we'll say Y minus 1.427. 427. Okay, so control save. All right. Now we're going to say we're going to rapid to G0, Z0, or 1 point, or 0.1. Z.1. And then we're going to wrap it over to this corner. Now remember, we're going to, since you guys got I'd rather have you guys work on the drill homework. We'll probably just go ahead and program this contour and that, because the drill this homework, it will help you better prepare for the final. So this will be more what's due next week. I don't want to give you more than that, so we'll just finish this contour as a class. Let's see. Yeah, I don't want to bury you guys too much. Okay, Z.1, and we're going to wrap it over here to our clearance plane, which is going to be X 3.230. 230, and our probably want to come in front of this 100 thousandths or better. So y minus 1 point. This being our finished, go 1.407 plus another 400. I get. Well, we really only need to move in an x, so we'll just go right to y minus 1.407. But I think we also need to add 30 thousandths for that. But we'll do that on our comp in. So this is technically right in line with the finish, where the finish pass is going to be. And we'll comp in on X. All right, so D1, Z minus 0.870. Well, now we'll go Z minus 0.890 and go full depth, because we're only cutting 20 off the front. We'll cut 20 off the floor. And then last thing, we'll turn the comps off and just run across the front here, because this is actually 800 thousandths and our cutter is only 750, so it's going to leave a little lip on the front. Okay, so really it'd probably be a good idea to cut that lip off first. Yeah, so let's do that. We'll wrap it over, leave the comps off, and wrap it over to just y minus 1.832, and we'll just put the center of the cutter right on there. Y minus 1.832. Sorry, I'm rabbit trailing here. X, same thing, X. Really, X should be in front of Y. X, 3.230. Phew. And now we'll go G1, Z minus 0.890. F50 point, losing my voice a little bit. And so I forgot to put the thing in there. All right, rapid, Z minus, that all looks good. And we'll just feed over to X minus 0.5. So we're basically just cutting this little bit of extra material off and making, I just don't want material on both sides of the cutter when I'm cutting this, this contour across the front. So we're going to clean that off first. X minus 0.5. F. Probably go 15 inches a minute now because we're not taking so much material, or maybe even 18. And then we'll go G0, Z.1. Now we're gonna wrap it over and cut our contour. Control save. Okay, so we're in position. It should be Z minus 0.890. I might give you guys some bonus points if you can go through this and find some problems with it during the week. Control save, or actually I will have a look at it, see if you can find something wrong, like 15 points or so. All right, so G41, because we're climb cutting on this side, so the cutter's to the left of the cutter path. G1, G41, and now we're going to feed right over to X 2.630. And into this Y minus 0.030, so it'd be Y minus 1.002. From here to here is 800. From here to here is 1.832, so from here to here is 1.032, and with the chamfer, it will back it up to Y minus 1.002. Now remember, we're cutting exactly the part geometry now. which makes it fun and easy, right? Okay, we need 50 inches a minute here. F. I'm not trying to make mistakes, but I bet I am. 50 point. And F 18 point. All right, so now we should be right on the corner here. We're ready to cut our chamfer. So we'll say X minus 2.6, 30 in X. Y minus 1.032. Oops. Y minus 0.032. And then we just scoot on over to X plus 0.030, easiest number all night. I caught my own mistake. 10 points for me. Control save. X 0.030. And I'm going to say X0 Y minus 1.002. Perfect. That cuts a nice little chamfer on there. These parts look so much better when the machine cuts the angles, and I wish we could have made them, because you can see exactly what I'm talking about. Okay, so now we got to comp out. And the big rule about this is you need to be sure you comp away from the part at least whatever comp that you have put in there. And that reminds me, I forgot to put the D value, H1, D1. F 18 inches a minute. Let's say G40, X, this is easy, minus 0.5, because your cutter is 3/8 radius, and so a ½ inch is 100 thousandths past that. Y, here's another kind of a rule. Since we cut our angle this way, you want to comp Y and X away from your last cut, or sometimes it will. One thing I've seen a machine do is this is kind of if you are using wear, like say you are program the cutter path and you're using a reground cutter and you have minus 0.025 in your wear. I have seen if you turn your comps off wrong right here, it will sit there and mill a taper on the move before it comps out. And you'll never know it until you put a reground end mill in there, and then you'll wonder why you're scrapping parts. So since we're angling out this way, you want to turn the comps off this way, so going away from the part in X and Y. So if you moved Y up here, it might tend to gouge back into it this way. But since you're going away in X and Y, that will, there's a right and a wrong way to turn the comps on and off, basically. Mostly off. You want to make sure you're going away from X and Y. So X minus 0.5, and then we have the 1.832. Nope. 1.802. Well, we're at 1.002, so it'd be Y minus 1.502. Y minus 1.502. All right, I'm going to save this. There won't be any additional homework on this part of the programming. We'll finish it. We will finish it next week because it's already 10 till 7 and we haven't taken any breaks. So what I just take a minute here and review this homework. And again, I'm going to put an announcement out about possible lab time. There's nothing certain about that as of now, but they're just wanting to know how many students might be interested in it. Obviously, it's not going to be a requirement, and if we did do lab time, it would be after the semester's over. Control save, but it would be kind of fun to go down there and try to run some of these programs. I must admit. All right, let's go full screen here. Let's look at the workbook. This is the assignment for this week, and it's kind of extensive, but like with drill cycles, once you have the first set, you don't have to write this out by hand. You can type it into Notepad. In fact, I'd prefer that because sometimes I have a tough time reading handwriting, even my own for that matter. But you need to go back and review the rules about G98 and G99. Because what the deal is, you would cut this row, probably then come over and drill this row. But between this hole and this hole, you can tell it G98. And it will hop over that bar, that hold down clamp in the middle. But it's got to be between these two holes. It's the hole before you want it to happen. So it's counterintuitive. And this is something that's going to be on the test. So let's maybe go back and just take a minute and review that rule. I'll show you where it's at. And that's pretty much the only tricky thing. Let's see here. K7. I didn't think to find that. Yeah, a couple minutes here. Tapping cycle. So this was the one we did last week. But it didn't have a clamp in the middle, and it didn't have any steps. So, deep hole. I would have thought, oh, you know what? Let's just go up here, say Control F, and G98. There's 49. And cycles, find the first one here. Return. So this is, that's how they kind of explain it. Return planes. All right, this is the example right here on page 74. So let's kind of look this over. So it's doing hole 1, which is pretty much this hole. It's got them numbered for you. Hole 1. Hole 2 is G99 still, because we left, that calls out G99 up here. Hole 3, so from 2 to 3 is G99. Now notice, it's getting ready to hop over this clamp, right? Because if it G99's on over, it's going to smash into it. So you can look at this for a good example of how the pattern, how your G98s and G99 work. So from hole 3 to 4, notice they put a G98 in there. So you would think the G98 would go here because it's for some reason and it's true, it's the hole before. And then once it drills hole 4, between hole 4 and on hole 5, see, so hole 4 has the G98 in it. So between 4 and 5, it actually goes back to G99, which tells it to go point to point to point to point. Notice also that in this line, the R value goes deeper because you got a step. So the last thing you want is to leave your R point way up here and be slowly feeding all that extra wasted time. So that's why we changed our R point to a minus value. They went 0.4, R minus 0.4, because the depth is 500, and we're still trying to say 100 off the flat. All right, so the rest of it was pretty cut and dry. It stays in G99 for the rest of the whole pattern because there's no reason not to. We've established a new R plane, So notice you can just change what you need to in that line, and it'll leave the rest of the can cycle intact. So apply this to the homework that's on down the page. Is can cycle exercise number 2, and it's probably way on down here. So it's on page 90. I remember. Pretty sure, yeah, it's on page 90. So all that information applies to this. Now, one other rule about that is you can change your R plane going from high to low. You would never start down here and then try to change your R plane to a higher plane, because what it will do is it will move over and then change the R plane up, effectively crashing your drill. So remember, always start high. So between this hole, depending on how you go, if you go this way, around this way, between this hole and this hole, that's where your G98 is going to be, and then from here to here, it's going to be G99, if that makes sense. So you can, if you want to write it out on paper and take a picture of it, really, you can pretty much. We'll have to talk about a few questions. So, okay, yeah, no problem. Now I forgot what I was saying, but you can email it to my email address. It's in the syllabus. Syllabus is up here. Or you can text it to me. Most of y'all have my phone number because I was texting everybody to remind everybody that we're still in school. Either way, I can grade it, whatever your format is. So that's pretty much class for tonight. And if anybody else has got questions, go ahead and ask now. Jeremiah, you had a question about summer classes. Do you have a microphone? You can just unmute. Mr. Jeremiah? Okay, that's fine. So what's your question about summer classes? I'm taking educational psychology. See you, Blake. See you, Trent. Remember that show called Romper Room? You guys are probably too young to know. Class I wanted to go starts May 15. Yeah. What class? I don't know. The class I'm taking is online. Mill internship. I think David Grady would be a pretty good guy to ask about that. I'm guessing he's going to say, I don't know. And here's the reason, is because the administrators are at the mercy of the legislators, and the legislators are at the mercy of the people and on down the food chain. So there's a lot of uncertainty right now about, what is going to be, what's it going to look. I know that they're talking about trying to make the lab available from, I got the email right here. Make the lab available from May 1st to May 27th. So my guess is David Grady will work very hard to make sure we can have groups of 10 or less in the lab. But I think that will be, at best. So I know Dave Grady, he's been emailing me a little bit, so you could probably just shoot him an email or ask him, because I don't really know the answer to that, but I can guess that he'll say he's not sure. Sorry, it's not a lot of help, but no problem. If you guys have any questions during the week, I know several of you are taking advantage of that, and I really enjoy hearing from you guys. You're not bugging me if you have questions. If I'm not getting back to you, it just means that I'm at work or something, or eating. If I'm eating dinner, I won't. Which class? Oh, Joe Martin. He's at class 2. I know I've mentioned before, my classes next semester are advanced mill it's going to be Saturdays from buckle up 8 a.m. to 4:30. And then intro to CNC lathe is Thursday and Friday from 5 to 10. So they're trying to, that Saturday thing's a 10-week thing. The Friday and Thursday is for 8 weeks. So they're trying to get everything done in the first 8 weeks in case there's some other outbreak or something that will at least get our credits. Can't decide if I want to try to get a job with the internship or wait till fall to do advanced mill. Well, if you ask me, I think you should wait till fall to do advanced mill. But you can work and take advanced mill too, so you can do both. I know I am. I know from internal, because I do Honeywell. I was doing Honeywell testing, and I know Honeywell is really chomping at the bit to get some people tested. There's a thing called essential employees, and so a lot of times machine tool falls into that category. I would recommend just about every job I've ever found in manufacturing has been on Craigslist. So if you get on Craigslist and look under manufacturing, I haven't done it recently, but that's a lot of employers post there. In fact, I got my current job at Procon from that, and I also got the college job from Craigslist as well as a teacher, my teaching job. So anybody else? Questions about the program or anything? If you think of anything that, feel free to text. All right, I think I'm. Okay, yeah, do that. He would have the most current knowledge of what's going on with the school. So, okay, I'm going to stop.